Matt Whalen here with some hacks for camera nerds. One thing I enjoy doing with action cameras like GoPro is taking long time-lapse sequences of natural events like cloud patterns or plants sprouting from seeds. Because these can be long sequences that last more than a day, I usually connect the camera USB port to an external battery. Even so, when I'm finished collecting these still images, I have to edit out the long stretches of time during the night where the camera is capturing very dark images. To solve this, I've set up an Arduino-based trigger system with a real-time clock module. This system is able to control a Yi 4K action camera so that it snaps a picture every 10 minutes between the hours of 6 a.m. and 6 p.m. After 6 p.m., the Arduino controller turns off the camera completely to minimize power consumption until the next morning at 6 a.m. when it turns it back on. Also, during the time between shots, the Arduino powers the camera down. Before I get into the details of how to build this, I'd like to take a minute to compare the Yi 4K action camera to its closest US counterpart, the Hero 4 Black from GoPro. Both of these cameras were introduced about 10 years ago, and they share many of the same design components. They are both able to record 4K video at 30 frames per second and still images up to 12 megapixels. They both use high-resolution Sony CMOS image sensors and use the Ambarella ISP chip for image processing. Their lenses are nearly identical with respect to field of view and f-number. Both have built-in USB I/O ports and Wi-Fi capability. But the Yi 4K camera has several features that make it a better choice for hackability. It has a built-in touchscreen display that doubles as a viewfinder and user control interface. It has a built-in Q20 mounting adapter for connecting tripods, lighting, or other photographic equipment. Most important for this hack, it has a single push-button interface that controls power on-off and camera still image trigger. Here's the step-by-step instructions for building this system. As I mentioned, the key to controlling the Yi 4K camera is to tap into the push-button interface. To do this, you need to carefully pry off its plastic covering. This will expose a copper ring with a center copper pad. Shorting the center conductor to the ring for varying time intervals enables control over on-off functions and start trigger, record, and stop record. A long time interval connection, about 2 seconds, turns the camera on or off. Once the camera is powered on, a short time interval connection, less than a second, will trigger a still image capture in photo mode or start a video recording in video mode. In video mode, a second short time interval connection will stop recording. As you can see here, I've soldered fine gauge wire to each of the copper contacts on the Yi camera. I've used an 8 to 10 inch pair of ribbon cable wires for this. The other end of the pair is connected to a discrete photo relay device, a TLP222G, to provide isolation between the Yi circuits and the Arduino interface. With this device, an output signal from one of the Arduino I/O ports triggers an LED photodiode pair in the TLP222G that produces a low resistance connection between the two cable wires. The Arduino model I'm using for this project is the Arduino Uno Rev 3 with the Atmel Atmega 328P processor connected to a DS3231 real-time clock shield. The combined cost for both of these components is less than $20. And there's great software support for the DS3231 RTC device, and customizing the built-in library functions to meet my requirements for controlling the Yi camera was fast and easy. I'll be posting the source code for this project to my GitHub repo soon. When I set up this system so that the Arduino controlled the Yi camera to turn on once every 10 minutes, take a single still picture, and then turn off and only do this between the hours of 6 a.m. and 6 p.m., the power consumption was reduced to a bare minimum. In fact, by connecting the Yi and the Arduino to a moderate-sized external battery, this system ran unattended for a full week. Here's a sample of a week-long time-lapse video of seed sprouting to show you how well this worked. If you enjoyed this video, please subscribe to my channel. A lot more to come.